a moment, forget about AGI, artificial general intelligence. The LLMs that we have currently got cannot even remember the logic in the reverse order. For example, if you trained an LLM saying that A is the mother of B, then the LLM cannot remember or tell you that B is the maybe son of A. So this is the problem with LLMs in the current world, and that is what this current paper, the reversal curse, is explaining us. The paper does not get into the details of why it might happen, except a couple of lines which we'll see at the end of the video. But the problem here is that this is a big limitation of LLMs, including GPT-4. Before I further move into the paper, I would like to quickly show you the demo of what is happening here. Let me go to my GPT-4, and then I have asked the question, who is Mary Lee Pfeiffer's son? This is, maybe if you do not know Hollywood much, you wouldn't know the answer. It says there are no public records or verified information available about a person, Mary Lee Pfeiffer, having a son. Okay, cool. Now I'm going to ask a different question. I'm going to ask, who is Tom Cruise's mom? So now when I ask this question, GPT-4, in this case one of the best GPT-4 in the world, and everybody has said like there are sparks of AGI, says Tom Cruise's mother is Mary Lee Pfeiffer. And the same thing when we asked who is Mary Lee Pfeiffer's son, it did not answer it is Tom Cruise. This is the exact same problem. The LLM has been trained saying that Tom Cruise's mom is Mary Lee Pfeiffer, but the LLM does not have the ability to link back the logic, the reverse logic, saying Mary Lee Pfeiffer's son is Tom Cruise. And it is not just for one celebrity. The researchers have proved that there are tons of celebrities where you see this problem, and they've also done fine-tuning to figure out that this further exists. Let me jump into the paper. The paper is called The Reversal Curse. LLMs trained on A is B, failed to learn B is A. I mean, if you're a kid, it's quite obvious, right? You get a kid maybe in KG1, KG2, if you're in India first standard or second standard, you tell the kid that this is this kid's mom. The kid would automatically know that for this particular mom, this is the son or a daughter. This is a very obvious, easy thing for human beings, because that's how we store things. We have a symmetric memory, we store different things. Like we know if A is the son of B, we know the reversal is also true for the B side. But that is not how LLMs work, is what this paper is proving. This is from a bunch of universities, including New York University, University of Sussex, Vanderbilt University. Great job. Like, I always like when somebody points out that LLMs are not really good. This actually quashes a lot of AGI arguments saying that, oh, GPT-4 shows sparks of AGI. So what is this here? So what they're calling as reversal curse is an LLM cannot automatically generalize to the reverse direction. So if a model is trained on a sentence A is B, then it cannot explicitly tell you that the B is A. Like it cannot say the reverse is true. And they've given a bunch of examples. And it's not just OpenAI model, the out-of-box model. They've also managed to fine-tune GPT-3. They managed to fine-tune Llama 1 models, and they've managed to create fictitious celebrities to figure out if it can anyways improve. It does not. So what kind of experiment that they managed to do? First, they simply asked GPT-4 this question, and it did not answer who's like Mary Lee Pfeiffer's son. And while in the first case, it actually managed to tell that who's Tom Cruise's mother. Like it manages to say who's Tom Cruise's mother, but in the other case, it did not do. Now, what have they done? They have tried to set up a couple of experiments. In one case, they try to fine-tune an LLM to train the LLM with synthetic facts in a particular order. So they had fictitious celebrities. They try to fine-tune the LLM in the same order. Just keep A is B in that order. So the Daphne Barrington is the director of A Journey Through Time. This is what they trained the LLM on. And then when they asked who is Daphne Barrington, the LLM managed to say the director of A Journey Through Time. But while they asked who directed A Journey Through Time, the LLM said randomly John Smith, like, some wrong answer. So now this is what they tried to evaluate with two different metrics. They took this thing and then they tried to create two different metrics or two different kind of experiments. In the first one, they try to measure the exact match. How many times the LLM does a particularly exact match. The second one is what is the increased likelihood. So if the LLM comes up with a new name, what is the chance of it being the right answer or the not the right answer? So they try to measure these two. And if you see the result, it's quite a surprising result. In fact, like if you see the models like GPT 3.5 Turbo llama 7 billion parameter model, llama 30 billion parameter model, the llama 65 billion parameter model. If you just keep the parent child of celebrity, so you go and ask who is the mom or dad of this particular celebrity, you can see that more than 35% of the time GPT 3.5 Turbo did the correct job of predicting who is the parent. But on the other hand, it could not predict the child. In fact, it is between 10 to 15%. It further goes down for llama 7 billion parameter model, llama 30 billion parameter model, and llama 65 billion parameter model. And this is one of the biggest problems that we could see in the LLM world currently, and what they call as reversal curse. And you can see that there have been related works almost in the same topic already before, explaining why this could be there and this is existing. But there is very interesting aspect, something that they're describing why this reversal curse might be happening in the first place. They're not going into the detail. They said like we leave this for the future work, why the reversal curse is in auto-regressive LLMs, but they provide a very simple sketch that might offer us some details. What is the simple sketch that they're providing? First, let me read the verbatim exactly, and then I'll share my thoughts about it. For now, we provide a brief sketch towards the explanation. When a model is updated on A is B, this gradient update may slightly alter the representation of A such that it contains information about B. It would make rational sense for this gradient update to also alter the representation of B to contain information about A. However, the gradient update is myopic, the important keyword there is myopic, and depends on the logits over B given A. Like if you know probability, just do P of B over A. And not having to predict A from B in the future. So what is happening here? So while the model is getting trained, see, the model training is a continuous process. That's why you have got learning rate, and it goes through a process of learning, huge amount of corpus. While the model is going through the learning, or while the model is being trained, when it comes across a fact, let's say it comes across a fact that A is B. So now what the model is going to do, or what the training process is going to do is, it's going to update the representation of A to include the information about B. That is what the gradient update is, where the model actually updates its weights. So model establishes relationships about B within the A. So it updates A's details to include the relationship with B. So this happens. While this does not ensure that on the B side, the model learns about A, so that it never learns to predict A from B in the future. Now A is Tom Cruise, B is Mary Lee Pfeiffer. So while you're training the model with the dataset, everything around Tom Cruise, the model learns that Mary Lee Pfeiffer, I'm not sure if I'm just pronouncing her name wrong. Please say sorry to her if I'm pronouncing her name wrong. Going back to the explanation. If the first one is Tom Cruise, and if Mary Lee Pfeiffer is there, the model updates the representation of Tom Cruise to include Mary Lee Pfeiffer as the mom. But when you talk about Mary Lee Pfeiffer, there could be like tons of Mary Lee Pfeiffer on the planet. So the model does not update Mary Lee Pfeiffer with Tom Cruise information. And this is also something you would see that there is a post note that they added. The point we are making does not rule out a meta learning story in which the information about A and B are symmetrically stored, thus avoiding the reversal curse. So if the information about A and B are symmetrically stored, that means when you get a new information about B with related to A, you update A and B both, then that case reversal curse does not exist. But that's not how auto-regressive large language models learn. But that's not how these are being trained. So this is a very interesting paper, to be honest. Like it brings out a very fundamental flaw that exists within large language models, while everybody is claiming that this is a sign of artificial general intelligence and people are worried about AI. I'm not saying people should be not worried about AI, but it's funny that a large language model, just a textual large language model, an auto-regressive model that is designed to predict the next word, cannot even explain the reversal logic or understand the reversal logic. Even if I use the word understand here, does not hold true, because it's not a sentient. Anyways, I loved reading this paper. If you are interested, like if you want something to read, go through this paper. It's a very English paper, a lot of things you can understand. They've also shared their complete code if you want to do this experiment for yourself. They've given the entire code on the GitHub repository for you to set up the experiment yourself and run it. You can also go here and then see the relationships that they have done, and you can see for all the celebrities what kind of responses they've done. For example, you can go inside the GPT 3.5 turbo and then see, okay, for example, let's say Wes Anderson. So you can see Wes Anderson's mother, in this case 0, Wes Anderson's father, in this case 0.6. And if you go, you can go and read about all the other celebrities. For example, in Tom Holland's case, the father, Dominic Holland, 1.0, but while in this case the reversal is also true. So you can go ahead and then read all these things. So whose parent was identified properly. It doesn't happen only with celebrities. It's very easy to do it with celebrities, but you understand the point about how large language models have got this reversal curse that does not let them learn the reverse logic unless until explicitly trained on the reversal logic as well. I hope this paper was helpful to you. I hope this video helped you understand something new. If you have any questions, let me know in the comment section. Otherwise, see you in another video. Happy prompting.